So let's take a look at a probability question from the 2010 Leaving Cert Ordinary Level paper. It's a question about arrangements. We're given that a code consists of a 4-digit number which is formed from the digits 3 to 9 inclusive. So no digit can occur more than once in the code. So just to figure out what kind of digits we could include in this, you could have something like 3, 4, 7, 8. That would be fine, a 4-digit code. You could have 4, 7, 6, 3. That would be fine. A code you couldn't have would be 4, 4, 7, 6. We're not allowed to repeat digits. So if we use a digit in the code, we cannot use that digit again. So the first question is very easy. It asks us to write down the smallest possible 4-digit code. So if we think about the numbers we have, 3, 4, 5, 6, 7, 8, and 9, well, if we go in numerical order from the lowest to highest and pick the lowest 4 numbers, the smallest code we could have is 3, 4, 5, 6. The questions 2 to 4 are going to rely on the fundamental principle of counting. So this states that if one event has m possible outcomes and another event has n possible outcomes, then the total possible outcomes is m times n. So if we relate that to our question, we're going to have our first digit and we're going to figure out how many possibilities is there for the first digit of our code. We'll write down how many possibilities is there for the second digit of our code. How many possibilities is there for the third digit of our code? How many possibilities is there for the fourth digit of our code? And then we're going to multiply those numbers together. So the first question just says how many different codes are possible. So we have 4 boxes here to represent the number of possibilities for each digit. For the first digit, we have the numbers 3, 4, 5, 6, 7, 8, and 9. That's 7 numbers, so there's 7 possibilities for the first digit. If we've used one of those numbers, we're not allowed to use that number again, and so there's only 6 possibilities for the second digit. Likewise, if we've used 2 digits now, there's only 5 possibilities for the third digit, and finally, if we've used 3 digits, there's only 4 possibilities out of the 7 numbers for the final digit. And if we multiply these numbers together, we get that the total amount of different codes that are possible is 840. There's going to be a condition placed on question 3, so we want to know how many of the 4-digit codes are greater than 6,000. To be greater than 6,000 means that it has to start with either a 6, a 7, an 8, or a 9. So in this example, the first digit in the code can only be one of 4 numbers, 6, 7, 8, or 9. Once we've used one of those digits, 6, 7, 8, or 9, there is 6 remaining digits that we can use, and then 5 digits remaining for the third place, and 4 digits remaining for the final spot. And again, if we multiply these together, we get that there's 480 of these 4-digit codes are greater than 6,000. The final question, again, there is restrictions placed on it. We want 4-digit codes that are divisible by 2. If we think of numbers that are divisible by 2, they must end in an even number. So they could end with 4, 6, or 8. So if we draw our 4 boxes again, and they must end with an even number, a number divisible by 2, there's 3 options for that final position. It's either a 4, a 6, or an 8. Once we've used the 4, 6, or 8, that means there's only 6 digits left. We can start with any of the remaining digits, so 6. There's 5 digits remaining that could go in the second position, and there's 4 digits remaining that could go in the third position. And if we multiply these together, we'll see that the number of 4-digit codes that are divisible by 2 is 360.